Okay, so in chapter 7, what we do is we're starting to talk about confidence intervals and how they're connected to what we consider a confidence level. You guys have had a little bit of experience in confidence intervals because I've asked you like the range of the usual values. I've asked values that are significantly low and significantly high. And those are akin to a confidence interval, except our confidence level was stuck at a particular amount. You know, it ended up being plus or minus 2 standard deviations, so that would send about 95% in the middle, right? So when we were looking at our data, we were saying that I wanted 95%, which is, you know, most people, right? So that I'd have this number, which is significantly low, and then this number right here, which is significantly high. Well, I should say any number beyond this cutoff would be significantly high. Any number beyond this cutoff would be significantly low. So we had these tails. Now, in each one of these cases, since 95% is in the middle, then I have about 2.5% on both sides, right? Okay. So the way we do this in most of the last section is I'd ask you guys for means and standard deviations, right? And then you could find the range of the usual values. So unfortunately 7.1 we're estimating proportion and not mean, but 7.2 we're actually going to do exactly this kind of idea. So they're very related to each other because what we do is we have what's called a test statistic. So our test statistic is a sample statistic that's related to basically the population parameter I'm looking for. So what I'm looking for eventually is I'm going to be asking us to estimate a value for the mean of the population. So in order to estimate the mean of the population, you guys agree that the mean of the sample should be relatively close, but there's going to be some fluctuation, right? That's why we have, you know, any value that's outside of this fluctuation, we'd say significantly low or significantly high. So that fluctuation allows for, you know, plus or minus 2 standard deviations from this particular test statistic. So, you know, x bar minus 2s to x bar plus 2s. So this really is kind of a confidence interval that I would kind of claim that, you know, the actual mean is between those two numbers, right? That's kind of my claim. So this is kind of the idea of this entire section is we have what's called a test statistic, and then we have these critical values, these z-scores that we bounce between. So yeah, that's pretty good. Now these numbers right here, these numbers 2, which are our critical values, which actually are represented as z-scores. You guys agree that 2 represents how many standard deviations I am above or below the mean? So when you look at standard deviations, you're really looking at the z-score represents how many standard deviations. So these two z-scores are tied to these spots right here, right? So when I say 95%, I mean plus or minus 2 standard deviations from this x bar, right? Okay. Now, if I was to like increase this to larger, so this would be our confidence level. If I was to, and this right here would be essentially our confidence interval. Can you see that this confidence level, this number right here is tied to these standard deviations? That if I increase this, then these standard deviations are going to have to go farther out, right? So if I got to like 99%, maybe these things would have to be plus or minus 3. So that's kind of our goal here. So what we first have to do is we have to be able to find these numbers right here. I have to be able to find these particular z-scores that are tied to areas. So like a first example would be find z alpha over 2 for a confidence level of, say, 90%. Now remember that when I say z alpha over 2, the reason why we're doing z alpha over 2 is because we're talking about 2 tails. So in this case, for this, alpha would be equal to 0.05 because it's what's missing from the 95%. Is that clear? Mm-hmm. So that means each one of these areas here would have to be alpha over 2. They'd be half of 5%, and this also would be alpha over 2, which would be half of 5%. That's why both of these things are 2.5%. So when I ask for a z alpha over 2, I'm asking for the z-score here. Actually, when I'm looking at this x bar is technically 0. So if I'm talking about a z-score, if the z-axis, this would be equal to 0 and then so on, right? So this would be -2 and this would be +2 if it's just z-scores. Now we do kind of send it over to x values eventually, right? That was kind of the whole idea of that before, is I'd be able to take x values to z values to probabilities, and then I could even work backwards. So, okay. So what I want to do is I want to be able to find these two numbers right here. I know it's not going to be plus or minus 2 because I've changed my inside area, right? Okay, so what I know, and we can kind of just do it pictorially, but we're going to get really good at this, doing this quickly, okay? So pictorially what I know is I have this bell-shaped curve, and I know that 90% is going to live in the middle, right?
Yes.
So how big are the tails? Well, what's alpha? What's missing? Yeah, alpha would be 0.10, right?
Yes.
So that means alpha over 2 is going to be half of that, so 0.05. So each one of these have a 5% area, right? We could do that in our head. So I know each one of these are 5%. So if this is equal to 0.05, remember that our table gives us area to the left, right? So if I'm going to actually try to find each one of these values, we can try to find this value. This is, they call this z alpha over 2, and this number, since it's centered at 0, is going to be negative z alpha over 2. So these two numbers will be the same but opposite in sign. Always, right? Because if we have because this thing is symmetric. So if this is z alpha over 2, what's the area to the left? What's this area? Yeah, because it's going to be 90%, which is the area in the middle, plus that alpha over 2, right? Okay. So that means my area to the left of that z value is going to be equal to 0.95. Now another way they say is very quick is you can also just go 1 minus alpha over 2. Is that clear? That you could do that quickly as well? Because the sum of the area is equal to 1, right?
Yes.
Okay, so that's just another quick way of doing it. You know alpha over 2 is equal to 0.05, so either way you're going to get 0.95, right? Whatever way you want to do it. If you want to do area to the left, you want to do 1 minus this tail, it's fine with me. Okay, so now that I know the area to the left is going to be 95% or 0.95, what I have to do is I go to my z-score table and I try to find 95 in the body of this graph, right? Because these are your probabilities.
It's down at the bottom, it's 1.64.
Yeah, this one is, this is that perfect one, isn't it? Mm-hmm. So what you're doing is usually you're looking for a number as close as possible, right? Every now and then you land right on it. You guys agree? But sometimes you get something that's close, like if I had like 90%, there's that 8997 that we've used a couple times, but so this right here is there's your 95, so it's going to be that z-score is going to be 1.645. So that means z alpha over 2 is equal to 1.645. We've actually done all this stuff before, right?
We have, I have right here.
Okay. Well, I'm saying we've done this in the previous section. You know, in order to go from probability to z-score to x value, you had to do this, right? So this is at least this is familiar. Okay, so now that we know how to find a z alpha over 2, which is essentially these things right here, right? These are our z alpha over 2s. Now that we know how to find these, I can find confidence intervals for a bunch of stuff now. So the way a confidence interval is done is let's talk about test statistics. So what a test statistic is really just the sample statistic for the population parameter. So like mean for the population, right? That's a population parameter, and it's got a test statistic of x bar. So this is the sample statistic. This is the population parameter. So you also have p, which would be proportion, and what we're going to use is we're going to use p hat, which would be the sample proportion. You're going to have sigma, which is the population standard deviation, and then you're going to have s for your test statistic. So we're going to be using these things as our estimators, essentially, with a little bit of fluctuation, right? We're going to have a little fluctuation here. Okay. So how these two are done, how these two confidence intervals for mean and proportion, they're done identically. So what you do is you take your test statistics, so your confidence interval will be your test statistic plus or minus z alpha over 2 times your z alpha over 2 times your standard deviation. And then this is going to be less than whatever your parameter is, okay? Less than your parameter. I'm running out of room. Parameter. And this is going to be less than your your test statistic plus Z alpha over 2 times your standard deviation. So that's how this is going to look. You're going to have your test statistic. Boy, it came out really ugly. But just like we had here, you had your test statistic minus 2 standard deviations to your test statistic plus 2 standard deviations. The difference is we're not using plus or minus 2 anymore. We're going to get more accurate with these. Okay? We're going to get better with these numbers. So when you're looking at the formula for proportion, they give you the equation for that, and kind of describe what it actually means, and I'm just going to write it out again, but it's I don't know why I'm looking it up, actually. No, I don't think so. So for proportion, so confidence interval, proportion is done by they say it's p hat minus e less than p hat plus e, where e is equal to z alpha over 2 times the square root of p hat times q hat all over n. So when we say E is just your z-score times, so this really represents your z-score, this represents your standard deviation. So this technically is the standard deviation for proportion. So when you look at that, like this part right here is your plus or minus E. Does that make sense? So you can write it even like, they usually write this because it looks cleaner. But you can write it this way. So p hat minus your z alpha over 2 times the square root of p hat times q hat all over n less than p hat plus your z alpha over 2 times the square root of p hat q hat all over n. So it's your test statistic plus or minus so many standard deviations. So remember, your z-score represents how many standard deviations, right? Does that make sense? Okay. So let's do an example. All right, so medicine usage. This will be good. That's a little fuzzy. So what we're going to do is we're going to do 22. So it says, in a survey of 305 adults aged 57 through 85, it was found that 81.7 of them use at least one prescription medicine. So all the other stuff is where it comes from. I do like how they cite the journal and everything. Okay, so it says, how many of the 305 subjects used at least one prescription medicine? So what they're looking for in Part A is they're actually asking for the test statistic. Sometimes they give you the number. Sometimes you have to find the number. So this is a good question. So what I know is for 22 is we know that there was 3,005 adults, right? And they said where 81.7% of them used prescription medicine, right? Used prescription medicine. Is that clear? Okay. So A says, well, how many of the 3,005 use this medicine? So how do you find that number? So if I know if this is the total and this is the percentage, how many people out of 3,005 are going to use it? Yeah, just multiply them, right? I know that 81.7% of people use it, right? So 81.7% of these guys. So remember that you have to put this in actually decimal land, right? Out of percentages. So that means your X value, which is how many people are going to use it, is going to be 0.817 multiplied by that 3,005. So like I said, sometimes they give you the x value, and I'm going to kind of show you the different ways that you're going to see it. So 0.817 times 3005. What I get is I get a.
Yep.
You guys agree? 2455. Okay, so I'm going to round it just to a whole number. Okay, so x is going to be equal to 2455. Now sometimes sometimes what they'll say is there are 2,455 people out of 3,005 adults that used it, and then they'll ask you for p hat. So right now what they did is, in this case, they gave us p hat was equal to 0.817. They gave us the proportion of people, and then they asked you to find the x value. Sometimes they might say, x is equal to 2455, and n is equal to 30005. So what if they gave us how many people and then this, and I ask you to find this p hat?
You divide.
Yeah, you know that p hat's going to be equal to the division of x over n, right? It's going to be x divided by n, so it'd be 2455 all over 3005, and that's actually how they found that number, right? You guys agree when you do a survey, you're gonna know this, not this, right? So you're gonna have to find that through division. Okay. But in this case, they gave you this and they asked you to find that. So this is the answer for A. Slide up. Sorry, I forgot I zoomed in, so it's looking bad. Yeah, if you go out of frame, let me know. Okay. B, they're asking, probably the confidence interval, but sometimes they ask it directly. Okay, so construct a 90% confidence interval estimate for percentage of adults 57 through 85 that use at least one prescription medicine. Remember that they have to keep this 57 through 85 because this is what they tested, right? Okay. So they want to say to build a 90% confidence interval. So in order to find a 90% confidence interval, is what we know is we're asked to find this. We want to find p hat minus e less than p hat plus e. They're asking us to find this confidence interval. Remember, we're not going to actually know this population parameter. I won't know it exactly. I'll just know that it's going to live between these things. Is that clear? I'm just going to know the allowable fluctuation, and I know that's going to live somewhere in there. And then we know where E is equal to that Z alpha over 2 times the square root of P hat all over Q hat divided by N. So let's start talking about the values that I know so far. What one of these letters do you know? You remember, you'll never know P. P is the population parameter, right? This is what we're estimating. Okay. So, okay, what's P hat? 0.817. So if I know P hat, what do I also know?
You know,
Q,
Q.
Q hat, yeah, I know Q
So
hat.
it's 1 minus 0.8.
Yep, it's going to be 1 minus this number. What is it?
0.183.
Makes sense. What also do we know? We know N. What's N? 3005. So I've taken care of everything here in E, right? Except the Z alpha over 2. You guys agree? So this is the last thing I need to know. So remember, Z alpha over 2, what's the confidence interval they want?
90.
They want 90. So in the middle, they want 0.90, right? So what's the area in the tail? 0.05, right? 0.05. So if I want this Z alpha over 2, which is this number right here, what's the area to the left?
90.
Good. So area left is 0.95. So that gives us a Z alpha over 2 of?
1.6.
Yeah. Oh, yeah, we just did it, didn't we? Okay, cool. So, and that's how these things are found, right? So now you know how to do everything. So let's put it all together. So let's find E first. So E is going to be equal to the Z alpha over 2, so 1.645. What I'm using this formula right here, okay? I'm using this to find E. So 1.645, because that's at Z alpha over 2, times the square root of P hat, which is 0.817, times Q hat, which is 0.183, all divided by N, which is 3005. What's really nice about this is all this is multiplication, so you don't have to have any extra parentheses everywhere, okay? So I'm just going to plug it in right as it sits. So 1.645 times the square root of 0.187, and then times 0.183 divided by 3005. And it's really nice that I don't really need any parentheses. So just go. So I'm going to take this out because remember that we're estimating a proportion, and a proportion is a probability. So what I need is I need 3 sig figs, just like we did in chapter 5, okay? So I'm going to take this out to 3 significant figures, all the way out to 116, okay? So this is 0.0116. So that means my interval, my confidence interval, is going to be p hat plus or minus that number, right? So now p hat minus e less than p hat plus e is going to be equal to this p hat, which is this number here. And I'm going to add and subtract that number. So this is 0.817 minus 0.0116 less than p less than 0.817 plus 0.0116. Now again, remember these are probabilities because this is proportions. So when I'm done adding these things, I'm going to round the 3 sig figs. So 0.817 minus 0.0116. So you can see the work right here. Those are my 2 numbers, so I'm going to round the 3 sig figs. So I'm going to stop at 5, and I'm going to take that 8 and turn it into a 9. So I get 0.805 less than p less than 0.829. You could also, so there's a couple ways that you can represent an interval. So to kind of give you guys an idea is graphically, this is kind of what it looks like. We have a bell-shaped curve where they want the area to be 90%. Okay? And what I know is that this is negative 1.645, this is positive 1.645, because that gives me the correct tail length, right? What we've just done is we've transferred this, these are z-scores, so it's centered at 0. We've transferred this to a bell-shaped curve, but for proportion, like this is now going to be values for p, these are going to be probabilities, so essentially p of x, where the center is, well, we can find the center between these things, but I'm not actually going to write p in there because p could be anywhere between, but what we know is that this number here is 0.805, and this number right here is 0.829, and that these tails are equal, that this is still 90% in the middle. And what I know is I know the actual p lives somewhere between these 2 numbers. It's not going to live directly in the middle. It could be any one of these numbers. Is that clear? All I know is that it's going to live 90% of the time. It's going to live in between these numbers. Other ways you can represent this interval. I'm going to slide this paper over here. So you can write it like this, or you can write it like this. I have 0.805 to 0.829. You guys remember, like, because it's a number line, this is 0.805 to 0.829. So remember, this is just a number line. So you can write it as an interval that way as well, okay? Just like in math class. Okay. I like this one a little bit better, but some students like this better because it's less marks. And I'll accept both of them. They mean the same thing. What I like about this one right here is that this says that the population parameter lives between those 2 numbers. This does too, but it's not nearly as informative. Okay. Any questions on that? It's not that bad, is it? Okay, so let me do an example that asks us to find the sample size. So there's a formula for sample size that I want to kind of show you guys, and it really is just E solved for n. Where are you? Why is this? Okay. So when they say find the sample size required to estimate the population, what they do is they give us this formula right here. And this formula right here is just the E formula solved for n, and I can kind of algebraically show you that. You know that E is equal to Z alpha over 2 times P hat Q hat all over n. So n is the size, right? So what I'm going to do is I'm going to solve this for n. So I'm going to divide by z alpha over 2, which is going to be equal to the square root of p hat times q hat all over n. Then I'm going to square it, so this entire thing is going to be squared. Is going to be equal to p hat times q hat all over n. So what I want to do is I'm going to, this is actually e squared all over z alpha over 2 squared. So in order to solve for n, what I prefer is n to be on top, and since these two expressions are monomials, I can flip them over. Basically, I'm cross-multiplying is what I'm doing, so send n over there. So when I cross-multiply these expressions, what you're going to get is you're going to get n all over p hat q hat is going to be equal to this z alpha over 2 squared, all divided by e squared. And then finally, to solve for n, I have to send that up to the numerator. So n is going to be equal to this z alpha over 2 squared times p hat times q hat all over e squared. So this this formula right here is like the formula for sample size is just your error formula solved for n, okay? Now you don't have to memorize it because they have it for you, okay? Remember, it's in that piece of paper that you guys are allowed to have. So there's two different ones that we know. So if p hat is known, what we use is we use this formula. If p hat is not known, what they do is they maximize the size of p and q. They maximize this number right here. The biggest the product of p hat and q hat can be, the largest number that's possible, is if they're both 50%. So like if you have two numbers that, you guys agree that p and q are related?
Mm-hmm.
So like if p is 0.25, then q has to be 0.75, right? And if you multiply that, you can see that I get 0.187. The biggest the product of these two numbers can be is 0.5 times 0.5. That's the largest they'll ever get, okay? So that's why they do that. So if you don't really know it, they just says, well, let's make it as big as possible. So that 0.25 really comes from those. Okay, so let's do it. So it says in 31 through 38, they say find the minimum sample size required to estimate the population proportion or percentage, and let's do chickenpox. So it says you plan to conduct a survey to estimate the percentage of adults who have had chickenpox. Find the number of people who must be surveyed if you want a 90%. No, I'm picking it. I don't want to do another 90%. Let's do a different one, okay? I'll do astrology. I don't know if I can. Okay, fine. I'll do astrology. So it says no, a Scientologist. I can't do it. I'm sorry. I got my limits. Video games. That looks fun. Okay, so 90%. Come on. Okay, I'll find it. All right. iOS market share. There's no astrology or hokum? Okay, we're good. All right, so it says you plan to develop a new iOS social gaming app and that you believe will surpass the success of Angry Birds and Facebook combined. In forecasting revenue, you need to estimate the percentage of all smartphones and tablet devices that use the iOS operating system. Android and other operating systems versus Android and other operating systems. So how many smartphones and tablets must be surveyed in order to be 99% confident that your estimate is in error by no more than 2 percentage points? This is fantastic. I like this one. Okay, so it's got everything. So letter A, they say assume nothing is known about the percentage. Now remember, there's two different ways that we're going to estimate this population is. One if p hat is known and one hat if p hat is not known, okay? So what they say is we know nothing about p hat, so we have to use the first formula, okay? So our formula, n is equal to z alpha over 2 squared times 0.25 all over what? All over e squared. So that's our formula. So what I have to do is I have to find all these values. So first thing they told us is they want to be 99% confident. So 99% confident, what does that give us? What of these letters does that give us? Yeah, indirectly gives us Z. You guys agree? Because remember that it says to be 99% confident. It means that in the area in the middle has to be 99%, right? So it's going to give us these. It's going to give us these values right here, right? So no matter what, you're going to have to find Z alpha over 2 for all these problems. So what's the area to the left? If this is 99%, what's the area in the tail?
0.995.
Yeah, because this is 0.005, right? It's half of 1%. You guys agree this is 1%, so this is half of 1%. So the area to the left is going to be the addition of those. Or it's going to be 1 minus this number, which still gives you the area left is, to the left, is equal to 1 minus alpha over 2, which is 1 minus 0.005, which is equal to 0.995. So that means I'm going to look for 0.995 in the body of my table, right? I have to go back to your z-score table, and in here I'm looking for 995, or at least a number that's closest to it. That's another perfect one.
Yep.
So 995 maps to 2.575. So this number right here is 2.575, which makes that number negative 2.575, right? What's kind of interesting is since you're squaring it, doesn't matter what you're using, right? So they always just say Z alpha over 2 is the positive version of it, okay? That's just their claim. Okay, so popular today. Okay, so let's so now we have this one, right? We have Z alpha over 2, we have the 0.25. What's E? How close do they want to be? How many percentage points?
2.
Yeah, they say with E needs to be within 2 percentage points, right? Now, what does percentage points mean in decimal land? 0.02. Is that clear? Okay, so now plug it all in. So N is equal to Z alpha over 2, which is that 2.575 squared times 0.25 all over 0.02 squared. So we'll just pop everything in and go.
Where'd the 2.575?
It comes from being 99% confident.
Okay.
You got it?
Yeah.
Cool. So again, since this is all multiplication and division, just you can plug it in just as it sits. So times 0.25 divided by 0.02 squared. Oh, I guess you can't. Let's try that again. Oh, I just forgot to. Okay. So what I get is 4144.14. Now, remember what this means is this is the maximum number of people that I need in order to get within 2 percentage points, right? This is the maximum number I need. So what am I going to round this to? If this is I need at least this much and no less.
Round up.
You have to round up. So in these n cases, all your numbers are always rounded up because this is the smallest number of people that I need. Is that clear? So that means that's not going to do it, is it? Because it's a little shy. So always round up. Always round up. And that's only in this particular case. So this is going to be 4145. Only in these estimating n problems. Sorry, this was number 36. Okay, so that was letter A. Letter B, n is equal to z alpha over 2 squared times p hat times q hat all over e squared. So what's nice is if you actually know something about the population proportion, you don't need as many people as what's going to happen here. So this number is going to get smaller, okay? So what they said is, for number 36, they say, assume in a recent survey we know about 43% of smartphones and tablets are actually using iOS. So they're saying about 43% are Apple, right? So what did they give you? Yeah, so what we know is p hat is equal to 0.43, so q hat is equal to Good, and that's the exact same, all the numbers are the same, you know, we know these two, so that means n is gonna be equal to, 2.575 squared times p hat times q hat all over 0.02 squared. It wasn't that much different. I was kind of hoping. Oh, the reason why it's not that much different is because these are pretty close to 50%. That's why the number's not that much different. So what I get is I get 4062.915, and all of these have to be rounded up, even though you would regularly round that number up, but they all have to be rounded up. So this is people. So they asked, did that additional survey have much numbers? So letter C, did that survey have much difference in these numbers? Did that let me use English. After taking that survey and finding the extra information of p hat, did that really change these numbers by a lot? Yeah, not in this case. You guys agree? The reason why it didn't change it very much in this case is because these two numbers were really close to 50%. If p hat happened to be like really small or really large, what I mean is close to 0% or close to 100%, then these numbers actually would be quite significant. They would be much different, but in this case, it didn't do anything, at least much. Okay.